Hello everybody, hope you guys are doing well. So today we will be continuing our journey in statistics, and today we would learn some more some more concepts, and then we'll go on from there. So today we will be starting with estimates of location. Okay, so estimates of a location. So basically variables. So what it is going to do is, so for example, if you have a column, right? Okay, let's have this. So if you have a column, so what, like these or what these functions are going to do is, um, so they are, instead of having multiple values, these are basically you are going to get a single value, which is going to indicate, or is going to give a sense of where is the majority of the values lying. So hence it is called as estimate of location. By estimate we mean, uh, so instead of having multiple values, we are going to give one value, which is basically going to indicate where is the maximum number of values lying. Okay, so first is basically there are some key terms. Okay, a basic step in exploring data is basically getting a typical value for each feature. Basically, that is an estimate where most of the data is located. That is basically trying to obtain the central tendency. Now, mean. Okay, so now there are some key terms that we need to understand here. First is mean. Mean is basically sum of all values divided by the number of values. So mean is synonymous, like mean or average is it is the same thing. They both indicate the same feature basically, and they are calculated as sum of sum of all values divided by total number of values. So we can say it's nothing but called as mean. Now then you have something called as weighted mean. So we'll see in depth like what is the drawback of when we use mean. And the weighted mean is basically sum of all values times a weight divided by the sum of the weights. So this is also called as a weighted average, right? So because the alternate word for it is weighted average. And so how is it calculated? It is basically um, sum of all values of value times a weight divided by the sum of sum of weights. The next thing that we have is something called as median, right? Median is basically the value such that one half of the data lies above and below. So basically, it is a value such that one half of values lie above it, and 1/2 uh, lie below it. Then we have something called as weighted mean. Again, weighted mean is something, sorry, weighted median. So we have something called as, okay. Now the value says that 1/2 of sum of the weight, like, so basically here will be 1/2 of sum of the weight above and 1/2 of sum of the weights below it. Now then we have something called as trimmed mean. Okay, so then we have trimmed mean. Basically, this is removing. Okay, so after we drop a fixed number of extreme value, removing mean calculated after removing extreme values. Then we have something called as outlier. Is basically something that is data which is very, okay, outlier, also called as extreme value. This is basically a value which is very different from majority of the values, right? Data that is very very different from most of the data. Okay, so first is okay, so now let's take um, mean, right? And let's try to understand what a mean is, and let's try to calculate, and let's try to understand what is the drawback of having a mean, right? Now, mean is basically the most basically it is going to give or basically mean is so mean is going to give an indication where the central central values are present. For example, if you have a set, you have three. If we calculate the mean, so the mean will be given by 3 plus, and then it will be total number of observations is 4, right? So it will be 2.75. So if we plot a graph over here, so if we, okay, okay, so if we plot our graph and say this is 1, let's say this is 1, this is 2, and then this is 3. So our values are concentrated between these two ranges, right? Maximum number of values are present between these two ranges. That is what it is trying to indicate. So this is what we are trying to say here. This is between, so this is 2, right? So this, so you have, so if you see in that way, you have 3 present here, 3 will be here, even 2 is in this range. and even one is, this is one, right? So yeah, so it's basically like moreover present. This is like the central distribution of the values, you can say. So here is the central value, or where the values are lying. Now, what is the drawback of using mean, right? Okay. So remember that the data that we are going to get for EDA will not be a clean data, right? It will have all sorts of outliers in it. So is mean a good is mean a good statistical measure to indicate the central value? Uh, we are trying to we are trying to understand that is mean a good statistical measure or not. So now what if we have an outlier data, right? Basically an outlier is uh, basically which is an extreme value in the data, right? So okay, for example, let's have a set, say 3 5 3 4 1 2, and then let's have a very large value like 1000. Now if you calculate the mean, so by formula this is 4, right? This is, you have 4 numbers, so it will be um it's going to be 3 plus, oh sorry, plus how many zeros? 1 2 3. This is 1 2 3 4 5 6 1 2 3. You have 6 zeros, and then you divide this by 4. So now what is going to happen to the mean? Okay, let's see. So now basically this is my outlier, right? Okay. Like this is not something which is I mean, this is a very high value, right? As when you compare to these all. So basically, what this will do is it will try to pull the mean towards itself. Now, if we calculate the mean, okay, yeah, let's just put this operation here and see what we get. So basically, the mean that you are getting now is this, right? So now the mean is what happened. So now the mean has changed to 2508, right? This is basically a very big value, right? So this is something which is very big, right? When compared. So what if we have another set, and in the same set we have values like 3 4 5, and now let's calculate the mean, right? So now the mean will be uh, so now what we are getting is basically 7, and this is 11, right? So this is 18 by 4. Okay. This 18 by 4 will be it's 9 by 2, which is 4.5, right? Now see the difference between the means, right? Just by adding one outlier value, the mean has significantly shifted, right? Oh, this is 4.5. So see this value and see the difference between here, right? This is so what it has done by this presence or by using this outlier, the mean has shifted. So where it has shifted towards the outlier or towards the higher value, right? So if you create a plot or a distribution, so basically let's have a graph here. Okay. And then if we plot this, right? So its mean or central value is going to be present here, right? Assuming this is 2500, right? And if we plot the mean uh for the graph that does not have a central value, it will be mean will be present here, right? So this is something called as um seven. This is 4.5. Yeah, this is 4.5, right? So just by addition, uh, see the difference between the two values. I mean, this is very much closer, and see this value. So basically, what happened is the moment we got an outlier, the mean shifted towards this, right? It became more and more towards the higher value. So is mean a good measure to represent the central value? No, like if we haven't performed any cleaning, then mean it will be more or the less will be affected by the outlier, right? So it will not give us the practical distribution of or the actual distribution of how the mean is lying. Now when I say outliers, for example, you have a form, right? So there are very few people who might fill. So for example, this is a form indicating your rating, right? For example, this is basically like a survey, right? Amazon survey. This is like an Amazon survey. This is your rating, right? Now, very few people will try to fill the rating very truthfully, right? Some people might just give 4 stars or 5 stars. So assume the rating is out of 4, right? Some people might blindly give it 4. Some very few people will think and give proper reviews, right? So what this does is, now if you don't remove this value, this kind of shifts the rating towards 4. So even though the actual rating is not towards 4, because of the presence of this outlier, the rating has shifted towards 4. Now, why is this important? Is because using this is how our Amazon is going to place our product, right? So if it has a good rating product, then Amazon will try to market it more, right? If it has a very bad rating product, then so that is basically where you see something called as paid reviews or coming into picture, right? So basically, so the person sitting at Amazon will have to take into consideration about these paid reviews as well, because not all reviews are truthful in nature. Some might not be a good indication, right? So then when you see, you get below it shows, right, the average rating. So remember, if it is 9, so the average is not counted like number of ratings or score of averages. If 9 people have given the rating and the rating is varied, right? So it does not calculate the rating as, so the total number of people giving rating is 9, and then here will be the sum of the ratings, right? So this will not won't give me the exact measure. This is averaged, meaning that it might have outliers in it. So yeah, someone has to perform cleaning here, right? So cleaning needs to be performed, else Amazon might be marketing around, because Amazon is a marketplace, right? It earns money through, no, you buy through Amazon. That is one mode. The other is basically it kind of markets your shop, right? On, or your whatever your outlet is on Amazon, on Amazon. So for it to market, it considers different parameters, right? So one of them is a good rating, right? So remember, you have a good whenever there is a sale, these products sell out fast because they are put on top, because Amazon wants to earn profit, right? By marketing it. So again, this is, if you consider it with outliers, so mean is not a very good representation of where the central value is, or where most number of people have given their values, or what the actual distribution of values is. Formula wise or mathematically, it is calculated as, mean is calculated as, so we say, so suppose if we have n number of reviews, and so each review is, say, like x1, x2, and this is basically the rating, right, given by people. So x1, x1, x2 are represent. So their mean will be calculated as summation as I till n, and then you like sum it over all the xi's, and then you divide how much, divided by number. So this n is basically the number of reviews given. So it is 4. It's not a other thing to note here. This is denoted as, okay, let's be very strict with what we use. So this is the thing denoted as small number of n, not capital. It's a small n. So this is basically, you go from the review 1 till the small n, and then you divide it by the number of views that we have. This is basically giving an indication of mean, right? This is the mathematical way, or the mathematical actual formula how the mean is calculated. A trimmed mean will eliminate the influence of. So then we have something called as trimmed mean. Right? We'll see trimmed mean, what does it does, and why does this, and how does it affect this formula. We'll see that later on. Now then is something called as weighted mean. Then okay, so then if you have mean, then why did we go to weighted mean, right? Like, what's the plus point of using, or advantage of using what's the major advantage or plus point of using weighted mean, right? Okay, now weighted mean, let's consider an example, right, to calculate weighted mean. So then we will come to know and where to use weighted mean for. Okay, so let's consider suppose you have like 3 subjects grade, right? So you have you have a subject grade of a student, right? So you have math, in that the person scored 90. Then you have science, in that the person scored 80. Then you have history, in that the person scored 70, right? So to find this mean, so mean will be very simple, right? What you do is, so what will be the mean score of this person? It will be 90 plus 80 plus 70, and then you divide it by 3, right? This is what the mean is. So this is basically 80. Now this is 80, not 86, 80. Now, so, and now, suppose that he has taken different credit hours, right? So example, this math has 4 credit hours, science has 3 credit hours, and history has 2 credit hours. So now to calculate, now Credit hours is basically this many number of classes he had, right? So so he attended say 4 classes for in order to obtain 990. Here he obtained 3, and here he went in for 2 history classes. And the weighted mean will be calculated as 90 times this weight. So this weight here is basically 4, right? And then um, plus again the weight for this is 3, right? So you kind of multiply it by the weight, and then again this is again the weight times uh, multiplied by the weight, right? So um, take if you multiply this, and then it will be sum of the weights, right? So the sum of the weights is 4 plus 3 plus 2. So this is basically giving me, which is something or the value basically present here uh, is basically, so it is equal to 82 point something, right? So this is something 82.2. So now let's analyze the difference, right? um okay, so basically um some variants are intrinsically more variable than others, and highly variable observations given a lower rate. The data does not equally represent the different groups that we are interested. So the now weighted mean is not a very good measure, right? Because the thing is, so like when should we use weighted mean? Because when some values are, if you would have calculated using mean, then you would have got this value. So like what's the advantage of taking the weights into consideration? Okay, so now here you can draw something, right? And this mean is getting affected by the weights, right? So for example, you have these weights that are coming into consideration, right? So the weighted mean is taking into consideration like which subject had most most utilization, or like most contribution towards his grade mark, right? Like towards his marks, whatever a percentage he got. So like which was more contributing, and like which no, in which subject did he spend more hours, and like what was the result he got there. So basically this mean is also affect this. The only difference between these two is basically these weights, right, that are taking over. So basically the mean is going to get affected by the weights. For example, let's consider one more example. For example, you have a portfolio, right? A market portfolio. So you have different assets. So you have asset A, asset B, and asset C. So uh, the return on your asset is say 5%, and so out of and from your total portfolio, it is contributing to 50% of your portfolio money. Then B, the return on B asset is 10%, and your weight or the contributing factor in your portfolio is 30%. Then you have an asset C. So basically the rate of interest on that asset is 15%, and the weight is again 20%. So if we calculate the average now here, why shouldn't we calculate this? Because each um, so we need to calculate the returns, right? Like the mean return I am getting. So basically so you cannot ignore the fact that the weight is going to affect the portfolio, right? Because um even though the return is 5%, but it is contributing to 50% of its portfolio weightage. Same. So this will have an effect on the mean of on the returns on the mean or the weighted mean return, right? So basically, he invested 50 times more, but the return he got was only 5%. So, for example, weighted mean is used in such conditions where we have. So, like, what if we try to calculate the mean? Like, what if we only take into consideration the mean? So the mean will be like 25, 30 by 3, right? So, the mean return here is will get is 10. But this 10 is not an accurate representation, right? The reason why this is not an accurate because um, so the contribution or the presence of weights is not fair, right? I mean, even though it's contributing 5%, but it has 50% assets that are contributing towards 5. So, I mean, is out of its portfolio, 100% portfolio, 50% is giving 5% returns, right? So, this would not give us a very fair advantage or very accurate measurement, right? So instead, what we do is we here use a weight. So we use weighted mean to calculate the mean, and that weighted mean will be weights multiplied by the rate of interest, right? So then you will get it. So then this will be my weighted mean. So let's take one more example of now basically we for example we are so nowadays even schools have this dashboard, right? Basically indicate that uh, basically gives an indication how was your performance, right, in your school academics. So suppose if we are preparing this dashboard, so suppose and then we say so each so like to pass an examination you will have to complete say some number of credit hours, right? Let's see what is credit hours. So basically credit hours represents the amount of academic work required to complete a course, right? So every course has been allotted certain number of hours depending on upon how the uh, difficulty of that subject is, and how many hours and how many topics are like need, and how many hours will it need to cover that topic, right? So depending upon that, the credit hours are calculated. So let's have different subjects, and then, so for example, we have math. So you have math, and then you have science, then you have history, and then these are subjects, right? Okay, so now we need to calculate how did the student perform, right? So then, okay, let's have, so basically this is the number of credit hours that we have, and one column is going to represent the grade that you got. Suppose you got 90% in math, right? So basically let this be the grade, and then this was 80, and then this is 85, right? And then suppose you have credit hours, so you have 4, so 3, 2, and 1. So basically this is the credit hours or number of hours required to complete that particular subject, and this is the grade that you got in that subject. So basically what we want to determine is we want to determine, so basically we want to determine the, or basically we want to find his performance, right? Now we want to find the student's academic performance. Like how did he perform well, and then how was his so now what we do is, so suppose if we calculate performance on using mean. So basically if we calculate, then since this is the highest value, our mean will be supportively be near this value, right? Or since you have three values near it, so it will um, try to put our grades toward that value, so that our mean, when we calculate the mean will be something which comes out as 86.6, right? This is what we get our mean. So does this indicate how well he performed in the next example? Is this a very true figure? We need to check that, right? Our goal is basically using statistics to understand, is this a perfect academic progress that is representing his classwork or not. Our aim goal is to understand that. So if we calculate the weighted mean, so basically we'll be multiplying the grade with the number of hours, right? So grade and then credit hours. So once you multiply that, then you will get the weighted mean rates. The weighted mean will be 82 point something. So suppose if my weighted mean is 82.92, this is my weighted mean. Now, now let's see like which one of them is a proper representation of his performance, right? And why? Now, what is going to happen if we do averages? The grade will contribute the highest grade. The average will try to be near the biggest possible value, right? Because it's calculating the average. That is how average has an effect, right, on the mean. So I mean that is how the values have effect on the mean. But now we say that this is a better representation. Why? Because we are also taking into consideration the number of hours allocated for that subject. So if we say um, so basically we are saying that um, basically this course, although he got higher score here, but then this is having more significant impact, right? Because it is taking 4 hours to complete. That means this subject might be a bit difficult subject to study, right? So even it was a difficult subject, still he was able to get a good score. And if he scores well in this is what is going to impact his academic performance, right? For example, low hour courses. So if it's a easy, if it's a lower hour course, and if it's an easy score, like if it's a low hour credit, that basically mean that this is an easy score, right? So like out of a class of 100, or 90% of students will be able to score marks in this. But if he wants to really come in top 3 or top 4, along with this, what he needs to do is he needs to have a good score in that course which has greater number of credits. So because the more the number of credits, more marks and more number of credits is what is going to affect his academic performance when compared to another other run. So whenever you have some weight, or for example like credit hours, or something like asset management portfolio, where you have certain number of assets and you want to contribute the total return revenue, at in those places, weighted average or weighted mean is a more valuable measure, because it will give more information about how the data, by taking into consideration the the amount of the amount of the percentage of assets that a person holds, and also the amount of and its contribution on to the uh, to its total portfolio, right? Now then let's see something called as median, right? So we say that mean is highly volatile, right? Because it can be significantly affected by outliers, right? Because what will happen is, if there is an outlier, then by default the mean will try to be towards the outlier value. That is how addition has an effect, right? Bigger value addition will try to move the values towards the bigger thing. Then we have something called as median, right? So busy median is basically more reliable than mean, right? Because median does not take into consideration the total value, right? I mean, basically median will so the definition by itself say that value is said to be median, where you have 50% data points below it and 50% data points above it. So median is calculated. So what he's trying to say is, if you have say if you have 30 observations, right? So if you have um, 30 observations, and then all are in ascending order, right? All are in ascending order, arranged in ascending order, and means from smaller to greater. Then the median will be, or the median, or the central value of the location, or the central distribution, or the central line around which the values will be distributed, will be uh, the will be that value or that observation, um, in so that such that 50% or half values are lying above it and half values are below it. So the only point or only advantage is here we are not taking into consideration the addition, right? We are basically arranging it and try to understand where the mean is based on the number of values that we have. So this does not have a significant effect on outliers, right? Even if an outlier value, so suppose you have instead of 30 you have 31, right? So the median would not move significantly towards the highest value. In fact, it will be somewhere between the 30th or between the 16th or the 17th observation, right? The median will lie there. And if you do not consider this, then it would be the 14th or the 15th value. So this is not having a very significant impact, even though you have a very high value or very outlier value. So basically, what it is says is the only condition is you need to arrange everything in ascending order, and the central value will be such that the half values are lying above it and half values are below it. So you have half values above and half values above below it. This is basically actually giving me the central tendency, right, along where the values are lying. Now, as we said that there was an issue with mean, right? It was getting highly affected through outliers. So then they came up with the concept of something called as calculating. So like even if you have outlier values, so we said that mean is significantly affected by outlier, right? Then they introduced something called as a concept of something called as trim mean, right? That kind of tries to remove or tries to overcome the drawback of mean, right? Or by or affecting outlier or the effect of outliers on mean. Let's see trim mean like and how it is formulated. So now if you calculate the what do you say trim mean, or if you see the formula for trim mean, it is not the same as that for average, right? Or for mean, like we are synonymous, right? Average and mean are synonymous. Then the formula for trim mean is given as so the variation of mean is trim mean, which you calculate by dropping a fixed number of sorted values at each end and then taking an average of the remaining values represented replacing the sorted values where the smallest next is the largest. The formula to compute mean p smallest with p smallest and largest values, because see the problem is of mean. So our main concern about mean was, if you have a very high value or if you have a very low value, right? So this is the problem with mean, right? So this is high value, and then the other is basically if you have um, and then you have something called as um, low. So you have basically two extremes, right? Low and low values, and so this is what is going to affect the mean, right? These are both which are going to create problem when you have a mean. So the solution to this is, what if we try to eliminate these, or what if we calculate the mean such that we only take into consideration the middle values and then remove the high possible values. So then what is going to happen is, if the value is very high, if you have a very high outlier, the mean will go towards outlier, and if you have a very low value, the mean will go towards that, right? So what we do is basically we try kind of ignore both of them, that is high and low. So if you kind of remove both the extremes, then the mean will be fair, right? You will try to, we will get the central tendency or the central value or the location of the point where the mean is present, right? So that is what is trend mean all about, right? So basically trend mean will eliminate the influence of all the extreme values, and it becomes difficult for one particular extreme, whether it be high or low, to manipulate the mean, thereby getting a mean thereby getting a very thereby getting a very fair value or of a central tendency of mean, right? However, still mean is not a very good value or a very good mean to represent the central values. So the most preferable way to represent it would be to use median, right? This will give us an exact, because we are arranging values in such a way that 50% towards are below it and 50 percent are above it. So this is basically will give us a very good central tendency or a central point. Now, even if you see the formula for trend mean, so the formula for mean was, okay, we had for mean we were doing I equal to 1 till n, right? But then same thing for trim. So now we are going to remove the extremes, right? So now instead of having 1 or 1 till n, so we are assuming that these two are the extremes, right? So these two both have been eliminated. So suppose if this is suppose this is my pth value. Suppose here is my p. So then what I'm going to do, my range will be from p plus 1 till, so this is here in between I have n numbers and I don't want this last term to come, right? So I'm going to take it by n minus p. So the range here will be from p plus 1, because I'm ignoring the leftmost extreme, and then p minus n by reducing the rightmost extreme. So this is how the formula will be calculated, right? And then it will be given as so, and then if you calculate the total number of observations, it will be n minus 2p, right? So this is basically representing the total number of observations that we have. I mean, you can just subtract this by this, and so if you subtract it, or this is my okay, so this is my first value, right? So if you just subtract p plus 1 minus n minus p, So what is going to happen is you're going to get the exact number of values. So basically it's going to give me, this is p minus, so this is going to be p minus n, and this is going to be plus when you open this minus sign. So it will be something like n minus 2. Oh, okay. Oh, sorry, I have done the other way around. So if you do the you subtract it the other way, you're going to give it. You're going to get this n minus 2p thing, but then you're also getting that minus one, right? So what's happening to that? Okay, so let's see. Like, suppose if you have a data set, right? So like, consider this to be my data set. So I don't know. Yeah. So if this is my, okay, now let's go to arrow. So like, if this is my data set, and what if I try to consider, if you try to remove 10% values from both ends? If you remove 10% values from here, and if you remove 10% values from here, so remember, so then the total number of values that we are left will be 10 minus 2 into 1, right? So that is basically coming to 8. So that is how we are getting that n minus 2p observations. So yeah, that is why we are getting this n minus 2p, because on both the ends I have removed. And then if you can count, like if you remove the 10%, then you get, so the trimmed data set will be looking like this, right? uh, if I have removed, so if I have removed 10% from both ends, then this is the reduced or the new data set that we have, right? So 1 2 3 4 5 6 7, no, if you count this 1 2 3, yeah, so if you count the number of observations, it will be 8, right? So then you can just generalize it to 10 minus 2p. So this is how you're getting that n minus 2p in the remainder. Yeah, I guess, yeah. So as for calculating medium, yeah, there are two ways. I mean, uh, basically to check whether which is the center. So there is one formula for odd, when you have an odd number of observation and when you have an even number of observation, right? So even number can be cannot be divided into exact, right? Odd number you can exactly divide it by, so it will be n plus 1 by 2 will be my 50th observation, and here you will have to use either it is going to be n, okay. So these all statistics are for numeric values, right? When you have some numeric, for example, how much did the average cost of the ticket was, and how much did an individual spend on the cost of ticket, what was the in-flight arrangement, so you can calculate that. So you will have two middle values, right? So for here it will be the n plus 1th observation plus the nth observation divided by 2. This is for even number, right? Because you are having two central values, you need to take the effect of both of them to get the median. And it's not necessary that there should be the value present in the data set. Like it will try to indicate the central value or where the values are being located. Okay. So yeah, that is all for today's session. I'll see you guys in the next one. Till that time, take care. Bye bye.